Hello everyone, welcome back. We are going to pick up where we left off in the previous video, which is going to be creating the columns. In the previous video, we set up the legwork for, or the preparation work for this part, so that we can come in here and continue on to really make the geometry. So let's continue from there. Let's see. So in the last part, we had the 4 points already selected where we want them to be, or roughly. And as you can see, this is what I meant when I was talking about that the two inner columns are not exactly where they should be if you were to divide the curve. So this is what you get. So 1 point is not exactly where you expect them to be, which is at the bottommost crossing. So we're gonna fix that real quick. Whilst I think the other 2 points are also not really, yeah, so it's next to it, but it's not close. So we're gonna fix that real quick. What we have here is we have the 4 points where we think they should be, or roughly, based on our rough estimates. And what we're gonna do is we're gonna find a point that is actually where there should be where they should be crossing. So I think it will be this point, if I look at it that way. So let's see, what can we do? We have this point, and what we'll need is actually the other points, which are these. Okay. So we can actually do closest point in order to find that point. Let's see, closest point, this one. P, I think it's the point to search. C is the cloud, which should be this one. And then we can make sure this is flattened. Select that back in there. And for this point, I assume the closest point to be that one, but let's see. It is actually one that is not the one we want. So from this, there's going to be a problem because we want it to be this point here, because that's the closest lowest point. So what we're going to do is, I believe in the previous part we had a further divisioning in selecting the lowest point. So we can actually use that here, no problem. Let's see if we can use any of these. So this is sorted by distance. I believe this one is also the lowest distance, so we can actually use that value in order to distinguish the lowest point. So we're going to use member index, and what this does is it finds from a list the indices that correspond to whatever value you put it in to search for. So for example, I want to operate on this set. I want you to find anything that has this value. So that will go into the M, member to search for, and the input will be indices where this is found. And these are the indices. And what I can do with this, I can select it using a list item from these points using the indices that we just got. And there we have all the lowest points. So we're going to replace this with the cloud to search from. In this way, what we enabled for ourselves is it will only search for the closest point at the bottommost point. So then it selected that one, which is what I expected. And for this one to be selected, the other one, which is also what I expected. So we can turn that off. And now that we get to this point where we really have the center point of where the column should be. So what we can do is, if you look at the photo, probably not this one. Let me find a better photo. This one might help us a lot better. What you can see is we actually have this point. Let me actually enable my pen tool. Okay, now I just have my pen tool. So what we did is this point here is this point, right? So the logic that we want to now use is I want to select this one, that back one, and this one. So let's get on here and come back. So let's see, we can do point closest again, basically the same thing. So I can actually select this one. So now the point to search from is these new points. The cloud, in this time, oh, actually, this is the wrong one. This is only searching for one point, but there is actually another one that lets you search for multiple points, which is just called closest points, plural. So if we can select that, this one give us additional input, which is the number of points to search for. So the same goes for point to search from, and the cloud can be, it can be this one actually. But one thing I'm worried about is within this set of point is also the point that this one resides in. So we might have to do some additional culling afterwards, but we'll see how that goes. And then we can input a number of points to search for. I would say 5 points to search for, because if you look at the image, we'll actually be having 5 points to actually look for. It will search for itself because that one is close to itself. It will search for that one, it will search for that one, and the one in the back. So in the end, we will have 5 points to look for. So we can say search closest 5 points, something like that, and that goes in there. So now what we have is we have, I think, 20 points. Yep, and each closest to their own tree. So these are the 5 points. And let's have a check our photo again. Looks about right. Okay. Now that we have these points, we need to connect them to the bottom, which is these two. What I suggest is we can actually use the I-beams actually maybe to use the endpoints. Let's say if I were to rotate this a bit, what I suggest is we can use, let's say this is the middle point, and upwards I think it will be this one and this one. You can use those 2 points of the I-beam and just move them down, and those will be our points, which will then reconnect 3 times to whatever beam that we found. So this one will go probably there, this one will go to the bottom, and like that. So let's get on to modeling and you'll see what I mean. So these are the 5 points. We need the I-beams. I believe we do have it, that one. Now the tricky part is, how do you identify which I-beam you have to select? That is indeed a tricky part. Let's see, what can we do? Let's see, what can we do? We have these points. Actually, are these points? These are points at center. I don't think they have a value. No, they don't have value. That's gonna be tricky to find these beams. Well, I can actually do point closest to geometry or point closest to something. Point closest. Find a point closest to a curve. Find closest point on a B-wrap. Closest point line, perhaps? Would that help? No, doesn't. But let's see if we can make something here or make use of these points. Oh, we do need to graph this. Actually, we can graph that part because we want each point to be reevaluated against all the others. And I believe maybe you can use the distancing to get something out of it, because we know the line that is straight above is going to be the one with the shortest distance. So we can actually do that. Let's use a sort to sort on these numerical values. And we're gonna sort it based on the I-beams themselves, like that. We might need to graph this, I'm not sure yet. How many numbers do I have? Okay, so if I were to do list item on the shortest distance, which is maybe I suspect 2.7 exactly, because the height from lowest point to I-beam is 2.7. So if I do this, what I've done is I've selected the first point or the first line that correspond to it, which I see 1, 2, and 3. I mean 4. So those are the beams that we want. And the question is, are they in the right order? So what I'm going to do is just use its point list based on this point. And just gonna do a really large number in order to see that. So 0, 1, 2, 3, 4. Okay. And from here, you know what? Let's evaluate this way. Let's do curve evaluation. We're gonna curve evaluation on this one. We're just gonna pick a point, so just one something, and the point will go there, and we can actually flatten this part. So 0, 1, 2, 3, 4. Okay, and this one 0, 1, 2, 3, 4. So okay, so they do correspond, so that's fine. That's actually very good. Oh, I deleted the list item that we need. Let's flatten that part. Okay, that's good. So what you can do now is do endpoints, because we just need the endpoints, and we're gonna move it down. Both of these points. It might be a good idea to. How am I gonna do this? Actually, let me try this one. Curve evaluation instead. We parameterize that curve, and in the parameter, we're just gonna use 0 and 1. That will give us the endpoints. Oh, right. I actually need to graph this then. Or need to graph that. And this one goes here. This also works. I should have, okay. Now what I'm wondering is, if I select branch, because I want to make sure that branch number 1 is actually the first 2 points and not something else, which I don't think it is, but I want to be sure, which it is, the first 2 branch. Okay, so we can move these points down by an amount that is determined by, let's start with 3.0 is smaller than 5, so we can have 3 to 5 meters. We just call it height of, let's just call it column height. Let's start with 3 meters. Oh, we have to go down, to be honest. Let's minus x. It doesn't look like it's a lot, so we probably have to increase this by a lot. Like, yeah, okay, that doesn't make sense after that, because the height between deck and lowest point is already 2.7. Yeah, that doesn't make sense. So let's start something by 5 to 15, and we put this at 10, let's say. So we can actually, this is a locally defined value. I don't think we will need it somewhere else, but if we do, we can just copy this and then put the parameter in the starting point. So that's, we can decide that later on. We don't have to do that now. But now that that works, so what we can do, we have these 5 points, and this becomes tricky because now we need to do another this component, this operation. What we want is from this point on, look at these 5 points and only select 3, because if you can see here, one of these only connects to 3, only have 3 legs. So that's gonna be interesting. What's the tree look like here? Okay, so I think we might need to graph this. Let's simplify and see what the tree looks like. Okay. this is interesting. Let's try this. Let's try closest point again. And we're gonna make another one of these, and we're just gonna call this closest point number is 3. Remember to change the name also, otherwise it's gonna be confusing. So we want you to select 3 points. The cloud you search from are these 20 points. Yeah. And you have to search from there. I'm not sure I'm getting the right points, but we'll see. I think I might have to flatten this. There we go. Because each point of these should be looking at all 20 points. There's no way that it will find those points. So it will always find somewhere one of these points, and no way it will find that because that will be further away from it. So logic wise, this should work, and we can actually test that by saying how many branches do we have here. Let's simplify and see what it looks like. Okay, so if you were to do list line, I'm sorry, you should get how many do we expect to have? We expect to have 8 times 3, that will be 24. There we go, 24 lines. And we can actually disable that. And now what we can do here is we say, let's do a variable pipe actually, because the thickness of these beams are not linear. As you can see, it's a lot thicker in the middle, so we can actually use that. We can say, what's this? Curve parameter for radii. Oh, right. You can just use this instead. So we can say 1 radius in the center, in the start, in the center, and at the end. These are the parameters we want to use. But remember to reparameterize it, otherwise these parameters probably will not work. And then we have the list of radii. We can say this is flat. I want to use the parameter, the diameter of the beams actually. Where are they? Diameter of the tubes. We can have that one. We can use that one there. And actually, it might be a good idea to move this further away. So I can select that, and oh right, I probably need to put this into a what do you call it? An entwine. Because remember, if you put in a merge, numerical values can be sorted in ways that you don't want it to be. And I can actually put another panel here in order for us to visualize what is actually going on. So we have that one. Maybe it would be nicer because I cannot apply expression there. So we're gonna use it as a number here that goes in there. One goes in here, the other one goes in there, and wait, actually, let me do this instead. Let's say that this one is x divided by 2, which would give us the radius, right? This one can actually go in there. Now this is going to be all the same, but what we want is, let's do another one. And then in here, we're just going to say, I don't know, x times 2, or x times 2.5 perhaps, which would give us a thicker beam. Oh, that's way too thick. Okay. Let's just do 2 instead, to the full size, something like that. We can change this later on, so I wouldn't fuss too much about this part at the moment. So that is our variable for those beams. The next one we're going to focus on is the cylindrical base, these two. Since we have the points here, was it? Yeah, here already. What we can do is we can just do a, how should we make this? Let's create a cylinder. Can I make that? Oh, cylinder. There we go. What does it need? A base plane. XY is good. A radius. Okay. And the height. Aha. Oh, actually, I should go there. How does this look like? Ah, doesn't look very pretty, but let's fix that. Let's start with a 1. What's it now? 0.5. Let's say something thicker, like that. And now it's actually the height actually goes up. Maybe if I do a negative height, it will go down. Let's see, -1. Okay, so it does go down, but I don't want it to go down that far. So what if I do 0.5? What do I get? That's actually doable. You can actually make 2. Can I cap this? Oh, can I cap that? Oh no, I'll just have to cap it afterwards using cap holes. I mean, if this is not okay with you, you can always change it, I suppose. Actually, let's do this a round cap, like that. Let's see. Well, they do sort of like stick into it, so I'm not sure it's actually this thing. Let's say it's something like that, more or less. No, wait, just go back to this instead. One thing I want to one thing I want to say is, you know what? No, we can do this, right? And then we can move it down. Then it will be in the center of our intersecting point. We can do it z-axis. We can use that number, the length of it, and then we can say x divided by 2. Actually minus, because it has to go down. There we go. So now we have our base. The next thing to tackle is actually the other base. Let me see. Well, there we go. Oh, you know what? I feel like this is still way too thick. Something like this. Let's just keep it like that. Let's not touch it anymore. And we'll be wasting more time on it. The next thing we want to do is actually the sort of concrete base that we want to make. So what I was thinking is we have these points, right? And what I want to do is from that point onwards, let's pick a blue color, easy to see. What I want to do is from these 2 points, which you already have, I want to move 2 points out, which creates 2 copies here and here. And I want to make, let's see, maybe 1 point here and here, so that I can, in the end, maybe combine these points into this kind of form and extrude that down, and we should have our base, theoretically. So let's try putting that to the test. The points I need are these. How am I going to get the vectors out of these points, actually? I might need to regroup them back. So let's trim the tree. You can actually remove the graph here, but the graph is used by so many things that it's just better to just trim the tree down. And what the trim tree does is actually it takes your path. As you can see, we have 2 levels of branches. It will try to eliminate the outer 1 branch because we set it to 1, and will give us back sort of when we before we even move it. And I'm just gonna confirm it, use the tree branch and set that to path 0, and I expect to select these 2 points, which I am, so that's good. What I want to do with this is I want to create an interpolated line in order to get the vectors to move these points, and I believe this is the wrong interpolate, so I need to flip the matrix in order to make the lines that I actually want. So those are the lines that I need. And now what I can do is use this line to get our tangencies. So we can say closest point to curve, because I know this one does give me a parameter that I can use. The points that closest to the curve is that one. The curve actually maybe I can use this point instead or not. The curve is that one that I know for sure. I might need to flatten this part in order to get my 8 points back. Or actually I can flatten the curve instead. Wait, that doesn't make any sense though. Because what I want to do is just get the points on that curve, and then from that curve on I can determine CRV evaluation. Because in CRV evaluation I need a parameter, therefore I can get these tangency vectors. So in the end I do need that t for my curve. So let's try to reparameterize that part. So then we have to reparameterize it again. This doesn't look good. Okay, so we can flatten this maybe. I would say that this doesn't look good either. So, but that's all these points exerted on this, which is not true. We only want these points to be exerted, but they're all zeros. It's because my curve is parameterized. Oh, the distance is 0. Oh, I'm sorry. I've been looking at the wrong things. I need the t. There we go. Yes, this is what I expect. There's a point at the start and a point at the end, and whatever's between, I don't know. So we can use this one, goes here, and that one. And now I should have my vectors. Let's see how my vectors look like. Vector display. Anchor point, vectors. They point to that direction. Okay. I actually want to have a point that doesn't go to that direction. So what I'm going to do is, let me enable that. Do I need that? Yeah, I need that. I want these vectors to be multiplied by a negative value and applied to, what's this? Well, that's the base. Applied to this point. And the structure of this point looks like that. So if I were to do a point list, and if I were to flatten this list, how would that ordering look like? So I can match that. This looks like, okay, 0, 1, so 0, 1, 2, 3, 4, 5, 6, 7. Aha, okay. And these points, how do they look like? 0, damn, the other way around. Wait, what if I take that one instead? This point looks better, but that's not the point I used. Oh, this is problematic. I may have to reflip this, I think. Yeah, so reflipping that does give me back my original ordering. So I have to reflip this basically. And now what I can do is say move according to that. No, wait, according to this. Okay. The points I want to move is obviously these points. I want it to be I want to be able to control it using an amplitude. But let's see, the point that we have here, actually, there's one important step here. I would prefer this to be a nice clean tree. This one doesn't make sense because now it's applying 2 vectors to 1 point. So I may have to flatten this part. Let's see. If I flatten this and I use another entwine, one goes in here and the other one is a negate from that flip, which goes in there. Actually, from this part, which goes in there. Oh, that's not good. I'll fix that later, don't worry. And then width of the base, what can we do here? Let's say we want to have what do we want to have? 2.0 is smaller than, I don't know, 3.5, and then we can put that at 2.5 meters. And this is going to be called the base width because it controls the width of the base. So we might want to put this somewhere here. Okay, let's leave it there. Yeah, let's leave it here. And what we have here is actually that, but our point is in that order. We do have 16 though. So I think we might have to reflip this, but that doesn't make sense, does it? Could be. Oh wait, we have these 4 points. Maybe we can use that one instead, because these points are on the line anyway. So we can actually use these points to move it. And the street structure from this point is to list, and I believe, oh, but still we need to apply the move. Each point will have 2 move, so I need to graph that in order to have each point connected, and then I will have, well, not flatten, I just need to flip it like that. So that's the point that we actually want. What's this? Oh, those are the base. There's somewhere a point still visible. Okay. Let's test our point. I should have 16 points, right? Yes, I do. Let's test it by using a branch tree. And let's simplify if I already haven't. Let's start with 2 so that I can select a nice range. Oh, it doesn't allow me to because okay, let's do this like that. And then I want to graph this once. Oh man, probably shouldn't flatten that. All I want is actually to select. Okay, you know what? Never mind. Let's do pointless instead. We can also determine using a pointless flattened because the ordering of the pair should be the same. So 1 and 0 is there, 2, 3, and it goes like that. Is that correct though? Because I thought our ordering, oh, okay, because we took a different source for the point. This one goes first to the right and then the bottom row. Since our amplitude also comes from that, then the order is still the same, which we have 1 pair, 2 pair, 3, and this is the last pair. Okay. Okay. I would say that's okay. That suits exactly what we want. So we have our points, and we still need 1 more, and we can actually take this one. We can continue on working on this one since it's already all the data already comes from this. We can actually use that one instead. Okay. Let's do that. Should we rotate a vector? Rotate vector. I do foresee one issue though, which is what I was planning to do is I will rotate the vector, right? Rotated by the z-axis in, let's say, 90 degrees, because you know the vectors change slightly, and then we can say vector display. You can actually see what's going on. That's the vector, and these are the anchors. So you can see that they all rotate to the same direction, which is not really helpful for us, because then we need to figure out, okay, which one needs to turn to 90 degrees or negative 90 degrees or 2070 degrees. That looks a lot like a lot more work for us in order to get that right. So what we're going to do is there's another neat little thing that we can use, which is called move away, move away from. And what this does is we present a base and a base as a reference point or reference geometry, whatever it is, and then geometry we want to move and the distance we want to move. So what we can do with that is we can say the base to move is going to be, I should probably take this one instead. So let's flatten this one here because I need to use this flipped because the branches of these three, that's the, this is the zero branch, wait. Oh crap, I've selected the other one, so I can actually use this one maybe, and this one can still go there. They're still going to be flattened anyway, so it doesn't really matter. But what I want, or are they? Oh no, I have to recheck this to make sure that the list of order is still correct. If I remember, the first pair is on top and then goes to the, oh, I need to flatten this. This is not good. No, it needs to have this ordering instead because that's how all our script has been ordered. It has been reflipped at the end, that's why. Or we can actually use this one and not flip it? No, that still doesn't make sense. Okay, let's keep it this way and not mess with this one. Let's take another fork from there because what we just need is the middle point from that. And what I want to achieve is if I were to select these two pairs, so we have 4 pairs and we can say average, which will give us the middle point of that. What we can also do is use the midpoint that we found that's under the belly, that point. But then we need to figure out up to where should it move down. Since we know that these points are always on the same plane, as you can see on the sides, this is going to work fine for us. So we're going to plug that into, what's this? Geometry to move. We want to move this one? Or this one? This one we want to move. Geometry to move away from is this one. And the distance is 10. Should the distance be 10? Let's get rid of that. I believe we have duplicate points now at the moment. Oh, you know what? We actually don't need to do this. We can say, wait, actually we do. Okay, so this is working fine. We have 4 branches with the 2 items we want to move, and 4 branches with a single point, and the distance to move can be the width, I think. So if we turn that back on, and then remove the second point, and now we need to find a way in order to combine these two together. This has a branching system which is 1 branch per column. This one is a bit tricky, so let's trim the tree down again in order to see what we have. I do think 4. Well, this one is a bit tricky. Trimming the tree down once, let's give it that. We cannot flip this because then we will have, let's see, how are the points listed on this one? I want to see that. Maybe you can reconstruct the list using that instead. So if I can zoom in here a bit, and let's put this here, flatten. Okay, the ordering is all messed up. But what if we flip the matrix once again? We cannot flip that one because it has 2 levels of branches. So if we do this, then it looks more like what we want because all of them are grouped together based on this. So I can actually use this one and say we flatten that part and then we partition this list into chunks that we can use. Like that. I want the size to be dictated somewhere that makes sense to us. I mean, we know it's 4 points, right? We know that. Should I just do it like not? Because I don't think that's going to change ever. Because if we want to change the geometry, we will have to change a lot of these anyway. So that will not change. So we can safely come here and say for size of partition. Yeah. Okay. And now I hope that we can now graph this. How does this look like? Let's simplify this again so that it has the same tree structure as that one. And now let's do another test by using branch tree to select the first branch in order to test that we have successfully selected what we think we have. I'm suspecting the first points. Okay. Now another problem arises. It kind of looks like we're shifting the problems actually, but this should be the last few steps. As you can see here, the order within the branches is totally nonsensical. So we need to reorder that. So one easy way to do is we can do it, reorder it based on a curve, and we can make that curve in a circle that they can create, which is a fit circle. So all the points will be sort of averaged in order to make the circle happen. So the radius will be whatever number it's going to be a decimal number for sure. But that's not important for us. What important is you have a curve that is usable for us in order to sort. So we can use sort along curve. That one, sort along curve. We can sort the same points with the same with the curve that created themselves. And now, if you put that in, you can see that the number makes much more sense. All of them. I'll bet the number, the 0 starts somewhere else. But for us, it's really no issue because we don't care about this ordering within the branch itself. So with that said, now what we can do is I think let's create a polyline, polyline, and set the boolean to true so that it's closed. I see something weird happening here. I might need to switch to shaded and turn off a lot of these in order to see it. I think the problem arises with how we move the curve. So let's switch a lot of these off. Let's switch that off. Let's switch this off. Turn off the grid. So we can solve this more easily. Let's turn off that. Let's turn. Yeah. So we're taking the wrong. Somewhere here we messed up. So we have to come in back and fix that one. Okay, let's go back here and have a look. Let's turn on our trusty point list in order to identify the problem. Should probably just keep this alive and not delete it every time. But okay, let's see. We have this point. 0. Oh, I need to flatten this, of course. So it goes like 0, 1, and then goes like that. Okay, and how does can I have that one? No, I cannot look at this. But what I can do is do a vector display of that from here. Oh, those are not points, of course. Aha. I think the ordering of this is actually not right, because if I look at this, actually, okay, and here we moved it, but we probably did not. We did not change this, so I don't think we need this actually, because we're flattening this already. I think it has to do with the ordering that we messed up, because it started out with 2 branches and 4 points, and that was being grafted, so it retained the order how it was, but now we've switched the tangency. So let's see what happens. Oh, it fixes itself, as you can see. Okay, in case you haven't see, you don't see it, let's observe. See how it crosses here. Oh, see how it crosses here very nicely, right? And if you plug in the old way, we messed up the ordering. It doesn't align anymore because this was actually not necessary in the first place. So that was quite an easy fix for us, so that's good. Like I mentioned, we have a polyline now. One thing we can now do is use a fillet edge corners. Let's use this one instead, and the fillet that we want to use. Oh no, 0, no, 0.2. Let's see how that looks like. That doesn't look like anything. This probably like that, maybe. That looks a lot better for us, at least. Okay, now that is done, let's take that off. We might need to move this back all the way. This one. Let's move all these down a bit, or not. No, doesn't matter. Let's move it like that. And this one can come up a bit. We do want to give it a color. I actually think the beams can have the same color as the horizontal ones. So let's leave it at that. While the base, maybe the base can have the same. The base is this one. Yeah, the base is this one. So perhaps the base can have the same color. Let's flatten that. Doesn't really matter that much to us. But for this, what we can do is let's do a boundary surface of this and then extrude that downwards. So this will be extruded down by, I don't know, to 1.5 meters perhaps. Looks more reasonable. And this is going to be extruded downwards. And this will have its own color, which is a dull grayish type of color, or a bit more white, doesn't matter. Not really that important at this moment. Okay, and there you have it. There's our pylons. And one thing we can do is we can actually change these. So we can say, let's add, hey, you know what? Let's add 5. I'm actually quite curious what happens. Oh, well, you can see. Apparently that happens. And you can actually go crazy with this. Let's say the starting distance is 20 meters and whatever is in between is like 10. This is gonna be okay. So this can happen. Looks like more like a sort of dam perhaps. But let's set it back to how it was. I think something might have broke. Okay, nothing broke. Nice, cool. So if you feel like having some fun with this, this is already one way you can do that. But let's set this back to where the original values were. And that should be it for our columns, for our supports. I'm gonna end this video here then. In the next part, we will, I think we might have to go and tackle the viewing parts, because that has implication to cutting the hole through our helices. Because when you have the healing part, if I can show you a picture real quick of it. Where is it? Do I even have one? Fortunately, I don't think I really have a good one. Maybe this one can help. What you can see here is the viewing part will cut through, will cut out sort of like a hole within the helixes. As you can see, one of the helix actually stops. This is a major helix, I believe, on this side, because the side of the viewing part is where the major helix begin. And you can see that it actually cuts, because we expected another helix to go here, and I think it actually cuts through. If I draw it right, it actually cuts through here instead and continue on through here. So we need to find a way to make this cut, but in order to make that cut, we need to have our viewing part first. So that's going to be what we're going to be tackling in the very next video. So until then, thank you for watching, and see you in the next one.